In this video, we're going to look at rules for exponents. And here in this section, we only talk about positive exponents and possibly zero. So we are not going to talk about negative exponents. We will cover those negative exponents or rational exponents later. So first we can compare these two expressions, 2x and x squared. So there's always a confusion between these two expressions. 2 times x, as we mentioned before, if there's nothing between, no symbols between the number and the variable, it means multiplication. So this means 2 times x or x times 2. Because multiplication has commutative property, so 2 times x equals x times 2. Well, we know that when we multiply x times 2, which means we add 2 copies of x. So 2x, in the other words, it's equal to x plus x. And we also talked about how to combine like terms. If you think of x as $1, so $1 plus $1, we get $2. And so backwards, $2 equals $1 plus $1. But x squared, it doesn't mean addition. Exponents, we mean multiplication. So when you have a positive exponent, it means we multiply 2 copies of x. So the operation, 2 copies. Although 2x is multiplication, it actually means addition, adding 2x. So we know that with numbers, for example, if you want to do 3 plus 3, you can also do it by multiplication. 2 times 3 equals 6. So that's the same thing. Okay, so this number 2 right there means we're adding 2 copies of 3. Add 2 copies of 3. Similarly, when we have 2x, it means we are adding 2 copies of x. Add 2 copies of x. And addition, we're doing addition. Well, x squared, when you raise 2, instead of have a 2 time in front of x or behind x, if this is 2 is raised, it actually means multiply 2 copies of x. Multiply 2 copies of x. So the biggest difference here is one of them is add, the other is multiply. Okay, so when we get a question, for example, 2x plus 3x, it means 2 copies of x plus 3 copies of x, we get 5 copies of x. But if we do multiplication, we're following different rule. We're first going to use the commutative property of multiplication to switch this x and the 3. So we can put a 2 and a 3 together, and the x and the x together. And because we cannot multiply 2 and x, but we can multiply 2 and 3. That's 6 and x times x, as we explained. When we multiply 2 copies of x, we can use a short notation for that, which is raise that 2. So we get x squared. Okay, now we are going to look at 5 rules for exponents. And these rules are for multiplication and division. So this section, we're not going to talk about addition or subtraction. Multiply and divide. All right, so let's go back to the definition of exponents one more time, that when we have, for example, x to the nth, what does it mean? It means, again, here n is a positive integer. So this n means n copies of x. So similar to x squared means whenever you have exponent, a power, it's multiplication. So we're going to multiply n copies of x. So we get x times x times x, depending on how many x we have. So I'm just going to put dots there to if we have more, n copies. Let's multiply n copies of x. So the first rule we're going to look at is if we have x squared times x to the third, what do we get? And before we give you the rule, I want to use the definition to do. All the rules are usually generated from the definition. So before I have the rule, I'm going to use the definition to do it. So x squared, as we explained, it means multiply 2 copies of x. So that's what x squared means. And this x means, this times here we just copy it. And x cubed means we multiply 3 copies of x. So now we know multiplication has associative property and commutative property. So we can, since the only operation we have is multiplication, we can get rid of all the parentheses and multiply them from left to right. And as you can see, we are multiplying 5 copies of x. And in that case, we can use the short notation x raised to 5th. And from this process, the 2 steps here we see, and that 5 exponent, the base x doesn't really change. So x squared times x cubed is we still get x. But the exponent is 5, which can be obtained by adding 2 and 3. And apparently you can see why we are adding 2 and 3, because we had 2 copies here and 3 copies there. Together, 2 plus 3, that gives us 5 copies. So the first formula we're going to have is x to the mth times x to the nth equals x to the m plus n. And that's what usually you see in most of the textbooks. But I can change the symbols a little bit to make it a little easier for us to memorize this formula. So what we're going to do is the base x, it could be x or y, anything, but I'm going to use letter B to represent the word base, the first letter B of base. And exponent, I'm going to call it E, because we have 2 exponents. So I'm going to call the first one E1 times the same base B, representing x here. And the second base, I'm going to call it E sub 2. And when we multiply the exponents of these two of B, and we are going to keep the base, adding the exponents, E1 plus E2. And notice that the original operation is multiplication. From the process, the definition you can see here, it's the quick way to get the answer is, instead of always using the definition, we can simply add exponents. So that's the first rule. All right, the second rule we're going to have is, what if we want to do x squared and then raised to the third? So notice this time there's only one base x, 2 exponents. We have two exponents here, but both of them are having the same base x. Well, in this case, there's only one base. Now, before we have the formula, we use the definition to do it. So we start from the outside exponent. This 3 means 3 copies. So when we do 3 copies, we're going to do 3 copies of everything inside the parentheses. We take 3 copies of x squared. That's just the definition of the exponent 3. Now, after we do that, and we can use the definition of the exponent again, this 2 means 2 copies of x, and this x squared again means 2 copies of x, and that square means 2 copies of x. And together, as you can see, we have 6 copies of x, so we got x to the 6. And this time we didn't get 5, we got 6. As you can see, we can get 6 from multiplying 2 and 3 instead of adding 2 and 3. And the reason is we are adding 3 copies of 2. When we add 3 copies of 2, it's like 2 plus 2 plus 2, but it can be done a quicker way. It's 2 times 3, which is 6. So the second formula we have is, usually in the textbook, you see the formula is written this way, x raised to m and then raised to n. And in this case, you will have, So you will have x to m times n. And when we write it, if I use b to represent the word base, and the exponent, we have exponent e in the parentheses, I'm going to call it e in and then e out. And what we do is we multiply, we keep the base, but we multiply the inside exponent and outside exponent. All right, so now let's look at the third case. So we may want to do x times y. So we may have two factors, a product in the base and raised to the second. So in this case, we still use the definition, two copies of whatever in the parentheses. So we have x times y, one copy, and x times y, two copies. And again, exponent means multiplication. We multiply two copies of xy. And we're going to use commutative property to switch this x and the y. We're going to get x and the x times x, and y times y. So we can only do that when we have all multiplications. Now we're going to multiply x times x, that's x squared, and y times y, which is y squared. And that multiplication sign can be omitted. As you can see, when we raise a product to a power, we can sort of distributing the exponent to each factor. So we raise each of them to that exponent. So we got x squared and y squared. So the formula usually written is when you have two factors, when you multiply something and raise it to an exponent, you are going to raise each one to that factor. And so let me put, so we may have a base 1 times base 2, the two of them, and raised to an exponent, you will raise each of them to that exponent. And this one also has a version for division. What if I have x divided by y? So we may have x divided by y and squared. By the definition, we multiply two copies of x divided by y. So two copies of whatever in the parentheses. And from the rule of multiplication of fractions, we multiply top times top. That's x times x squared, and bottom times bottom, y squared. So as you can see, it's like raising the numerator to the exponent and the denominator to the exponent. So the other version, which is similar to the third one, when we change multiplication to division, you can raise the top when a numerator to the exponent and the bottom to the exponent. So I'm going to put, so the top and the bottom, and raise them to an exponent. You can raise the top to the exponent and raise the bottom to the exponent. So I'm using these symbols to help us memorizing the formulas, the rules. The last formula we're going to have is for a similar version to number 1. Instead of having multiplication, we're going to have a division. So what if we want you to do x third divided by x squared instead of multiplying them? So by the definition, we know it's x third means multiplying 3 copies of x. X squared means multiplying 2 copies of x. And we know how to reduce the fractions. Similarly to that, we can cross out the common factors, x and x. And we end up with just x, which means x to the first. And you can see this one can be obtained by subtracting 2 from 3. And from the process of reducing, we can see the top has 3 copies of x. The bottom has 2. They have 2 copies of x in common. So we are crossing out 2 copies of x from 3 copies of x. So 3 minus 2 gives us 1 copy left. Okay, so the last formula we have, normally we put it as x to the nth divided by x to the nth. We're going to keep the base x, and instead of adding them, we're going to subtract the exponents, and it's always the top exponent minus the bottom. And or I can use the version, say, the top exponent, maybe put an e top, and divide by b raised to e bottom, and which is equal to the top keeping base and top minus the bottom exponent.